Today I'd like to talk to you about arithmetic progression. What exactly is arithmetic progression? Arithmetic progression is a progression of numbers with a common difference. So if you think of the numbers 5, 10, 15, 20, 25, you have an arithmetic progression where the starting number of the series is 5, the end number is 25, and the difference between each member is 5 because the numbers are going up by 5, and there are 5 terms in the progression. Let's generalize it. Let's say that A is the first term. Let's say L is the last term. Let's say that D is the difference, and let's say N is the number of terms. So the first term is A, then the second term has to be A plus D because the difference is D. The third term is A plus 2D. The fourth term is A plus 3D, and so on. So from this we can see that the nth term will be A plus n minus 1 times D. Because when we are looking at the fourth term, it is 3D, or 1 less than 4. So the nth term has to be n minus 1 times D. Now suppose we want to add all the numbers that are in an arithmetic progression. In other words, let's represent this as S. So here the first term is A, the second term is A plus D, the third term is A plus 2D, and we keep going until we get to the very last term, which is L. So the term before that has to be L minus D, and the term before that has to be L minus 2D. Now I'm going to write this from the back to the front. So I'm going to write this as L plus L minus D plus L minus 2D plus, and you keep going until you get to A plus 2D plus A plus D plus A. Now, after I have written this front to back and back to front, if I add these two things, I get 2S, and notice what happens here. This is A plus L. When you add the second terms, A plus D and L minus D, the plus D and the minus D cancel, and you are left with another A plus L. And when you look at the third term, you got A plus 2D, and here you got L minus 2D. The plus 2D and the minus 2D cancel, and again you got A plus L. So in other words, you have a total of n A plus L's. So 2S is n times A plus L, or S is n over 2 times A plus L. These are two equations that you should remember when you're considering an arithmetic progression. Now let's put this to good use. Let's think of a problem. What is the sum of all the numbers between 1 and 100 that are divisible by 3? So we are looking at all the numbers between 1 and 100. What is our first term going to be? It's not 1, it's not divisible by 2, it's not 2, but it is 3. And what is our last term? It has to be 99. So the question is, how many terms are in this arithmetic progression? So here's the equation. So n equals, or the nth term, which in this case is 99, which is the last term, this equals the first term, which is 3, plus n minus 1 times 3. This is the first term, this is the last term. There are n terms in this, we don't know what that is, and the difference is 3 because in this problem every number is divisible by 3. So 99 equals 3 plus 3n minus 3, or 99 is 3n, or n is 33. So there are 33 terms in the progression, in this arithmetic progression. Let's find the sum of all these numbers. So the sum is n divided by 2, so 33 divided by 2 times a plus l. A is 3 and the last term is 99. So you got 33 divided by 2 times 102, or 33 times 51, and you can do the math yourself and come up with the sum of all the numbers between 1 and 100 that are divisible by 3. So there's an example of an arithmetic progression. The whole thing is beautiful. Say magnifique.